All right, let's dive right into it. Welcome to this explainer where we're going to tackle the absolute panic of production deployments. If you've ever felt that awful sinking feeling in your stomach when your perfectly crafted code hits a server and just instantly shatters, yeah, you are definitely in the right place. Today, we're mapping out the actual roadmap to gaining infrastructure literacy as a backend developer.
Oh man, staring at this exact SSL handshake exception for 40 minutes is practically a rite of passage for us. It's universal backend engineer trauma, right? You know the drill. The most frustrating part is that the API works flawlessly when you hit it from your Chrome browser. But the exact second your Java backend running in Kubernetes tries to connect, it just vomits this massive wall of text. And right then, it hits you. You might be a wizard at building microservices, but you don't fully understand how these systems actually talk to each other.
So that brings us to a really fundamental question. What actually happens after the request leaves your REST controller? Look, we excel at writing business logic. We design gorgeous database schemas and perfectly structured APIs. But to actually fix things when production goes down in flames, we have to answer this question. We have to stop blindly relying on the DevOps team to parachute in and save us. We need to follow that request out into the wild.
Here's the real secret, though. You absolutely do not need to be a site reliability engineer or some Linux kernel hacker or a network admin. You just need what we call infrastructure literacy. It basically means understanding those critical layers where your application code collides with the outside world. It's about knowing exactly where failures happen so you can actually debug them intelligently instead of just throwing your hands up.
Honestly, this contrast is exactly why the legendary excuse, well, it works on my machine, even exists. Your local environment is literally just the application code. But a real production system? That's your code, plus the runtime, the networking, the heavy infrastructure, and all those strict security layers. Your local laptop is completely missing all that surrounding context. So a successful local run guarantees absolutely nothing about how it'll survive in production.
Okay, let's jump into Section 1. The mental model. Let's see how building a layer-based approach gives us a map through the wilderness of a production request.
Every single request in production has to survive this specific gauntlet. It starts at the client and DNS, hits a load balancer, routes through a Kubernetes ingress down to a service, drops into a pod, and only then does it actually reach your code. And here's the kicker. Every production issue belongs to one of these specific steps. By memorizing this journey, your search space gets tiny real fast. You stop panicking and you start isolating the actual failing layer. Moving right along to Section 2, Networking and DNS Traps. Time to tackle the invisible network drops and DNS caching traps that freeze your apps in total silence.
Picture this. Your Spring Boot app suddenly stops responding, completely dead in the water. But CPU and memory? Totally fine. You probably hit a network black hole. HTTP runs on TCP, which needs a strict three-way handshake. The connection timeout is exactly how long your app waits for that handshake. The read timeout is how long it waits for the server to actually spit back data. If you don't explicitly configure these in your HTTP clients, your thread pool just fills up waiting forever, silently suffocating your application.
Now, DNS caching is a totally different beast. DNS is basically the internet's phone book, translating a domain to an IP using an A record, or to another domain with a CNAME. But it's not instantaneous. Operating systems and JVMs cache these records using a time-to-live, or TTL. Meaning, if a database admin moves your database to a brand new IP, your app might aggressively keep calling the old dead IP until that TTL finally expires. It is a classic trap, and it catches everyone.
Let's hit Section 3, Demystifying TLS and Security. We're stepping into the most intimidating territory for backend devs, cryptographic handshakes. Let's break it down.
Before a single byte of your beautiful JSON payload goes over the wire on HTTPS, this crazy strict cryptographic sequence has to happen flawlessly. First, the TCP handshake. Second, they exchange keys and verify identities with certificates. Only then do you get to Step 3, encrypted data flow. If anything goes wrong in Step 2, like it doesn't recognize the certificate authority, the JVM doesn't care, it will unceremoniously drop the connection right there.
And that brings us to key stores versus trust stores, which honestly trips up so many of us. Think of a key store as your server's literal passport. It holds your private key when you're the one serving data. The trust store, though, that holds the public certificates of external authorities you trust when you're the client making a call. The trick to fixing most SSL exceptions is remembering the JVM is incredibly paranoid. You often have to manually inject an internal company cert straight into your trust store.
Oh, and watch out for this one: host name verification. The JVM explicitly checks if the domain you tried to hit matches the subject alternative name, or SAN, that's actually listed on the certificate. If you try to be clever, bypass DNS, and hit a raw internal IP address directly, like 10.0.0.5, but the cert is strictly registered for api.company.com, your JVM is going to aggressively block it. You literally have to call the domain name.
Section 4. Surviving containers in Kubernetes. Welcome to the orchestration layer, where our code gets wrapped up in ephemeral containers and thrown across a cluster.
Listen, at the end of the day, your app is just a process running on a Linux kernel. Before you blame Java for crashing on startup with a port already in use error, pull out this toolkit. A simple lso-i command will instantly tell you if an orphaned zombie process from an hour ago is secretly holding port 8080 hostage. Or use curl-v to see exactly what the network is doing. These are absolutely your best friends in the terminal.
Now here is a massive network illusion that gets developers every single day. Localhost in your IDE, that refers to your actual physical laptop. But localhost inside a Docker container, that strictly refers to the isolated tiny network inside that specific container. This is exactly why your Dockerized app throws a connection refused error when it tries to find a Postgres database running happily on your host machine. They're literally living in two different network universes.
So, you move up to Kubernetes, you deploy your pod, it totally says running, but Postman just gives you a 503 service unavailable. Why? Well, Kubernetes uses readiness probes to literally ask your app, hey, are you actually ready for traffic? If your Spring Boot app is still slowly warming up its database pool, KS acts like a bouncer and blocks traffic. Or even simpler, if your app is on port 9000 but KS is looking for a target port of 8080, traffic just hits a brick wall. Finally, Section 5. Observability and layer-based thinking. Let's talk about the absolute ultimate superpower for distributed systems.
Imagine a single user request bouncing through 10 different microservices before it fails. Without distributed tracing, you're stuck manually hunting through logs on 10 different servers. Absolute nightmare. But if you generate a unique X correlation ID right at the gateway and pass it through every single service using MDC, you just paste one ID into your log aggregator and boom, you get an instant visual timeline. You pinpoint exactly who dropped the ball in milliseconds.
We've covered a ton of ground in this explainer. The big takeaway is this: when you finally understand the infrastructure wrapped around your code, production completely stops feeling mysterious. Debugging stops being frantic guessing and becomes actual engineering. So I'll leave you with this thought. The next time those production alarms start blaring at 2 a.m., are you going to be the one guessing in the dark or the one engineering the solution? Your roadmap is ready. Thanks for hanging out with me. Keep learning, and I'll catch you next time.